All right. So, last time we talked about how to go about figuring out your normal distribution curve, finding out how it is spread out amongst your data, and then finding probabilities for numbers that were actually on your x-axis. Now we're going to talk about how you can find probabilities when the x value is not one of your standard deviations, okay? Because it can very well happen. That's when you use your calculator. Now, I say this to let you guys know that if they ask you to find the probability of something and one of your numbers is one of your standard deviations, then that's when you use the 68, the 95, and the 99 percentages. Okay? Do not use your calculator for those types, okay? Because they're going to expect you to know the breakdown of the normal distribution curve. Okay? I'll say that again because a lot of times when I say things, you guys don't hear me the first time, so I'm going to say it again the second time, okay? If they give you a question, they ask you to find the probability, and it's one of your standard deviations, you have to use the 68, the 95, and the 99 percentile breakdown that we talked about the other day. Okay? But if it's not, this is what you do. Okay? You go to your calculator. Everybody pull out your calculator if you haven't pulled it out. I have pictures here, so no one should get lost by what we're doing. You press the second button, and then you press the bars button. Bars is located right beside clear. Something to help you out. You see that word in blue? What?
Distribution.
Distribution. What type of distribution? Normal. There we go. Then you go down to option 2, which says normal CDF. Now, if your screen looks like mine, then you type in the lower bound, press enter, the upper bound, press enter, whatever the mean is, press enter, whatever standard deviation, press enter, and then press paste. Okay? It's very simple. I mean, you just fill everything in. However, if your calculator does not look like mine, and everybody should know both ways, then you fill it in exactly as you see. Whatever the upper bound is, you type it with the comma. The lower bound, comma, the mean, comma, the standard deviation, and then close the parenthesis and click enter. Okay? No spaces in between the upper bound, lower bound, mean, or standard deviation. No spaces, just one full thing. Sorry, we need to make a correction. Lower first, then upper. I do apologize. You gotta make that change. So again, make that change. It was the lower bound first and the upper bound. My apologies. Lower bound, upper bound means standard deviation. Okay? So let's look at an example. We're going to go back and we're going to look at the pod. Okay? And we're going to do a few to kind of continue with that. It says, find the probability that a woman has a height greater than 1.6 meters. Now, 1.6, was that on your x-axis for your normal distribution curve?
No.
No, it wasn't. 1.62 was the closest thing that you have, but you can't use the closest. So basically, you're trying to figure out 1.6, everything that's greater than that. Okay? What was the mean? And the standard deviation? Okay, thank you. This was mostly for video purposes. I didn't record the pod. So, since you recognize that that's not a value on your standard deviations, you go into your calculator, you press what?
Second
bars. You go down to option
2.
2, and normal CDF will pop up. Either you're going to have the list, like so, or you're going to have just a blank. Okay? So, what you do is you plug in your lower bound. Now, lower bound represents the smallest number that has divided your region, the area you're trying to find, okay? So as you see, it's everything from 1.6 and greater. So 1.6 is actually your lower bound. So you type 1.6 and then you type in a comma. The comma? Mean, standard deviation. Alright? Now you have to type in your upper bound. Your upper bound. Now it's supposed to be everything that's greater than 1.6. But if this is supposed to be something that gets really, 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 something in there to represent a really, really large number. So a good rule of thumb is to do 9e to the 99. Basically 9 times 10 to the 99th power, a super big number. Sorry, no parentheses. I don't know why I just did that. Then comma. Now if you're like, hold on, where's the E, Miss Anderson? E, you press the second button and then you press the comma button. You see something that says E?
Nope.
That's where E is. It's not exponential E, it is scientific notation E. Is everybody okay?
Exponential E is low.
Yeah, exponential E is the lowercase e. This is scientific notation E.
What did you get that? So why would you not use
Second column.
Why would you not use 1.86?
Because there's other numbers after this, because it's getting really, really small. So we want to try to get a super, super, super big number so that it takes into account as much as we possibly can. Everyone okay? Now you type the mean, which is 1.68, comma, and then you type the standard deviation, and then you close off the parenthesis, and you click enter. And we get
Error syntax.
0.909.
0.909. Is that rounded three significant figures correctly?
There is.
Awesome. All right, let's look at the next one. It says find the probability that a woman has a height between 1.59 and 1.75. Are either of those numbers on our standard deviations? No. So this time you're looking for 1.59, 1.75, everything between. So we go back. We go to second bars, option 2. And start typing away. What's your lower bound? 1.59. What's your upper bound? 1.79. Oh, 75. Mean and standard deviation. And then you get your probability.
Did you get selected again?
Did you get a good?
No error syntax.
36368.
0.811.
No, it's 0.82.
0.812. Anybody not getting these numbers? Find the probability that a woman has a height less than 1.7. Is that on your standard deviations?
No.
No. So you have to do it again. But this time,
Your upper bound.
what's your lower bound?
It's gonna be 0. No, it's gonna be negative 9e99.
Negative 9e to the 99. So because you want a really, 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 really small number, yes, into the negatives. So anytime it's going to be less than something, use negative 9e to the 99 as your lower bound. If it's ever greater than something, use positive 9e to the 99. How do you get the e again?
Second comma.
Second comma.
Now, why can't you use, well, oh. Wait. Oh, gosh, I hate
Got an answer.
0.631.
0.631.
Yes. Confirmed.
Question mark.
Why do we put the negative 9e thing again?
Because we wanted everything that was less than 1.7, so we needed a really super small number because we're talking about all the area that's less than 1.7. So a really, really small number all the way up to 1.7. We need to get all that area that's underneath the curve. So that's why we use the negative version of a super, super big number. Now, the only time you use your calculator to find your probabilities is when?
When it's the big boy,
When
boy.
the X bro is not on your
Abnormal
bro.
distribution boy.
Okay, so I am recording, so I need someone to say it properly. What is it? When do we use this?
When it's not normal distribution.
When it's not one of
When the X value is not
normal
one of those standard deviations.
Thank you. When one of your X values is not the standard
I
deviation.
said better, faster, and louder, so.
I
Yes.
applaud you.
I tried it.
No, So, going the other way, if you're given the percentage area and are asked to find the corresponding value to it, that is called inverse normal calculation. Now, the one thing you have to be aware of is when you're looking for these values is that it needs to be the area to the left whenever you use your graphing calculator. That meaning is that if it says the probability is 80% for some x value that's greater, you need to use the area to the left. So if you draw your normal distribution curve and you come out to be this, when in your diagram, when you're drawing, you can't plug in this probability into your calculator. You have to plug in the probability that's to the left of that x value. So how do you find that? You just subtract it from 1 or 100%, depending on how they give the answer to you, whether it's a probability or it's a percentage. Here we go. How do you figure this out? This is what you use when you're trying to figure out the x value. Now you're given the percentage, you're given the probability. Now you're looking for these numbers, the numbers that are along your x-axis. So you go back to second, you click bars, and this time you go to option 3, inverse norm. And then everything will be there. Area basically represents the area underneath the curve. Now, of course, we're talking about the area that's to the left of whatever this x value is that you're looking for. So you'll type that in, and you'll type it in as a decimal, okay? You always type it in as a decimal. You type in your mean, whatever that is, your standard deviation, whatever that is, and click paste. Or, here's the normal breakdown. Inverse norm, area as a decimal, mean, and then standard deviation. No space in between these, okay? No space in between them. So we're going to look at another example where you would use inverse norm versus normal CDF. You got a second to write this down? So, the volume of cartons of milk are normally distributed with a mean of 995 milliliters and a standard deviation of 5 milliliters. It is known that 10% of the cartons have a volume less than x. Find the value of x. So real quick, if we were to graph out a normal distribution curve, it's basically saying that 10% of your cartons have a volume that's less than some x value. That's what we're looking for. We're trying to figure out what that x value is so that way 10% of the cartons are less than that value. So this is 10%. How do you convert that to a decimal? So it's going to be 0.1 or 0.10. Just move it over 2 decimal places. So is this already the area to the left of that x value? Yes, it is. So you don't have to worry about doing any type of subtraction. So now you go into your calculator. You press the second button. You press the bars button. And you go to option 3, inverse norm. So if it pops up, just inverse norm with the parenthesis, what do you type in?
Area means standard deviation.
So your area is 0.1, and area means area underneath the curve. What's our mean? 995. And what's our standard deviation? 5. Close it out, click enter, and we will get our x value, which is so 989 when we round to 3 significant figures. So this value tells you that 10% of whatever we have, when we talk about cartons of milk, are going to be less than 989 milliliters. Okay? Let's take a look at this one. And I want you guys to actually do this one on your own. Sorry, this is a repeat of the question. I don't know why